In this next video, we're going to talk about work done by gravity, and that's a concept that's sometimes very poorly understood, and it's kind of confusing. How can gravity do work? But let's try to explain starting here. Let's say we have an object with mass m sitting on the ground, and some force pushes the object upward a distance of h above the ground. So in this case, we have a force which has to be equal to the force of gravity to push the block up at a uniform velocity. If this force is bigger in magnitude than the force of gravity, it will actually accelerate upward, and then the object will gain both potential and kinetic energy. So to keep it from gaining kinetic energy, we're going to make the force that pushes it upward just equal to the force of gravity, equal in magnitude, it's opposite direction, so that the block will very slowly move up at a constant velocity until it reaches the height we're trying to get it to. That means that the work done by this force, so the work done by the force is equal to the force times the displacement. Of course, these are vector quantities, and so we have to multiply it with the dot product. So this is equal to the magnitude of the force times the magnitude of the displacement times the cosine of the angle between them. But in this case, the angle between them is 0 because we have the force pushing straight up, the displacement being straight up, so the angle between them is 0, so the cosine of 0 degrees equals 1, and so this is equal to the magnitude of the force, which is mg times the displacement, which is h, so we can see that the work done by the force is equal to mgh. So now you say, what is the work done by gravity? Well, here it kind of strains the brain a little bit because you say, well, the gravity isn't doing any work. The gravity is pointing downward and the block is moving up, so how can gravity do work? But hang with me for just a moment. Let's just use the same basic equation. So now we're going to calculate the work done by the force of gravity, which is equal to the force of gravity dot the displacement. So we use the very same definition, and let's see what happens. So the force due to gravity is actually this one right here. It's a minus mg because it's pointing in negative y direction. So this is equal to minus mg in the y direction, and we're going to dot that or multiply it as a dot product with the displacement, and the displacement is h in the positive y direction, so that's h in the y direction like that. So this is equal to minus mgh times y dot y dot y. So these are the two unit vectors that are now dotted together, and of course, since they're only 1 unit long each and they're pointing in the same direction, that means that it's y, that it's this is equal to 1 times the cosine of the angle between them, so minus mgh times 1 times the cosine of theta. Now this is the angle between these two unit vectors, and those two unit vectors are both positive, pointing upward, so therefore the angle between them is 0, and the cosine of 0 is 1. And so this becomes minus mgh. So the work done by the force of gravity is equal in magnitude to the work done by the force that pushes it up, but it's a negative quantity. That's because the force of gravity is pointing downward and the block is going up, which means that if we have the block up here at a height h and we allow the block to come down because of the force of gravity back down to the ground, then the work done by gravity will be positive. So when an object is lowered in elevation, the work done by gravity is positive. When an object is risen up in elevation, then the work done by gravity is a negative quantity. And the amount, the absolute value of it, is exactly the same as the work done to get it to that height at a constant speed without acceleration. So hopefully that explanation helps you understand what we mean by the work done by gravity and why it's negative.